All right, time for my favorite acronym, CPCTC. It's fun to say and easy to use, hopefully. So, CPCTC stands for corresponding parts of congruent triangles are congruent. It's a justification. It's going to be used in a lot of proofs from now on. Before we get into how it's used, I have a seemingly unrelated question to ask. Which triangle congruence shortcut should you use to prove that triangles KBC and ACB are congruent? Did you pick AAS? I hope you did, because that's the answer. So let's actually do that proof right now, starting, as always, by stating the givens. Angle K and angle A are fine, but for these two, we need to give three-letter names. That's also given. And then everybody's favorite property, it's the reflexive property. That gives us more than enough information to say that triangle KBC is congruent to triangle ACB by angle, side. There we go. But what if instead of asking you to prove the triangles are congruent, I instead ask you to prove something about a pair of sides? This pair of sides specifically. These sides aren't mentioned in the previous thing at all. We only used BC. So how can we say something about those sides? Well, turns out that corresponding parts of congruent triangles are congruent. By proving that those triangles are congruent, we can say that any parts of those triangles we haven't already talked about are also congruent. Meaning that a proof about saying KB is congruent to AC would look exactly the same as this, but with one extra step. A step justified, let's make that a bit clearer, a step justified by CPCTC. Let's see a different one. Once again, which triangle congruence shortcut would you use here? I hope you said SAS, because that's what we're looking for. Once again, we'll start with the givens, as always. And we've only got those two givens. We'll need one more thing. We'll need the A for our SAS. How could we get it? This color is a clue. Oh, good. It is the vertical angles theorem. And we're going to say that angle CAB is congruent to angle YAD, I guess. In either case, this tells us that triangle back is congruent to triangle day by the SAS postulate. So, having already done that proof, now we need to say that angle C is congruent to angle E. So, how to do that? Like almost all of the proofs we're going to do involving CPCTC, it's going to be the same thing that we've been practicing with one extra step, where we say that these extra pieces are congruent because of CPCTC. The nice thing about this is that it gives us an excuse to practice all of the previous triangle congruence shortcuts that we tried before. And to that end, we're going to have some practice problems from section 4.4. Going to do numbers 6 through 10. So, have a nice Thanksgiving, everybody.